Hey guys, welcome back. We're going to move on to lesson 5.7. Lesson 5.7 is about using congruent triangles. We're going to basically be doing a lot of proofs, mixing in side, 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 angle, side, HL, angle, angle, side, and angle, side, angle. So all of them kind of mixed together. All right, so what am I doing? Presenting my screen and we'll get started. All right, so for lesson 5.7, it says, how can you use congruent triangles to prove other statements? So pretty much what we're going to be doing, if you look at, let me scroll down. If you look at the first proof, instead of proving the triangle's congruent, you're asked to prove something else is congruent. Like for instance, that FG is congruent to HJ. So think about this for a second. Once you know the two triangles are congruent, doesn't that mean that everything about each triangle is congruent? Okay, so what I mean by that is if I know that this triangle right here is congruent to this triangle right here, then that means every angle of this triangle is congruent to its corresponding angle in this one. Every side in this triangle is congruent to every side in its corresponding location in the other triangle. So that's the goal. We want to prove the triangles are congruent, and then that'll allow me to get to the next statement of proving another piece, okay? So when it says, how can you use triangles to prove other statements? We're going to say, once we prove triangles congruent by side, 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 angle, side, HL, angle, side, angle, or what was the last one? Angle, angle, side. Hold on. Let's go down to the next line. Or angle, angle, side. Then all parts of the two triangles are congruent. Okay, so we're going to jump right into our first proof. Today we're just doing a bunch of proofs together. All right, so the first proof, I'm going to set it up statements and reasons. Statements and reasons. All right. So the first statement is always a given, as we know. So K is midpoint of FJ and GH. Just trying to take a little bit of a shortcut. All right. So what does that allow you to conclude? Okay. If you're told that K is the midpoint of FJ and K is the midpoint of GF, what does that allow you to conclude? Well, if K is the midpoint of this segment, that means that FK is congruent to KJ. Now, I do realize it is not drawn to scale. They do not look congruent, but that's okay. We're just going to go with it. It was a drawing done by me or another teacher, and it wasn't the best drawing. So it's all right. And if K is the midpoint of this segment, that means that GK is congruent to HK. So I'm going to write those pieces of information down. That FK is congruent to JK, and that GK is congruent to HK. And that's based on what? It's based on our knowledge of the definition of midpoints. All right. The next thing we're going to list, what else do we know looking at the diagram? You know, angle 1 is congruent to angle 2. How do I know that? They're vertical angles. Angle 1 is congruent to angle 2. Vertical angles. All right, remember, once you have, I should have been putting stars. Once you have your 3 stars, your 3 congruency statements, you might have enough to say that the triangles are congruent. So let's look. Is this triangle congruent to this one? And we're going to be using as our justification either side, 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 side angle side, HL, angle side angle, or angle angle side. They are congruent by side, angle, side, side, angle, side. So you can say the triangle, and I'm going to name my first one as FKG. So my second one has to be named. If I went from F to K, I have to go from J to K. So J, K, H. And that's by side, angle, side. Now that is where our proofs ended in the last few sections, but we're going to be taking our proof one step further now. Right? After proving that the triangles are congruent, now we're asked to prove that this piece is congruent to that one. Well, once we prove the triangles are congruent, that means everything about this triangle is congruent to its corresponding partner over here. So since those two segments match up, they have to be congruent. So I simply say that I know that FG is congruent to HJ. And the reason I know that, and this is, the notation's a little kind of not confusing, but you just have to get used to it. It's because congruent triangles, you're basically telling me because I just proved the triangles are congruent, because I now know the triangles are congruent, that implies corresponding parts congruent. Congruent triangles implies congruent parts. All right, congruent triangles implies corresponding congruent parts. All right, let's try the next one. All right, so I'm going to set up statements and reasons. All right, so the first is a given that BF is congruent to FG and that DF is congruent to FH. So let's write that down and I'll mark it. BF is congruent to FG and DF is congruent to FH. We already have two stars. We already have two congruency statements. So I just need one more to prove the triangles are congruent. Does anyone see anything else that's congruent? Do we see our vertical angles? Angle 1 is congruent to angle 2. I can say angle 1 is congruent to angle 2. How did I know that? Because they're vertical angles. So vertical angles congruent. Now I have my 3 stars, so I should be able to prove that the triangles are congruent. So again, you're using either side, 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 angle, side, HL, angle, side angle, or angle, angle, side. And based on the markings, I know the triangles are congruent by side, angle, side. So side, angle, side, and it's triangle. You can name the first triangle however you'd like. You just have to name the second triangle consistently. So I'm going to say DBF is congruent to triangle HGF. All right, and then finally, oh no, I ran out of room. Let's see. That's going to help. I need this to move up, and it's not moving up. Okay, so I'm going to have to move this back to where it belongs. I'm going to have to bring number 4 over to the side here just because I can't write down here. It's not going to let me. So statement 4 and reason 4. I'm trying to prove that angle D is congruent to angle H, which now I know angle D has to be congruent to angle H because the two triangles are congruent. And that means everything about the one triangle is congruent to everything in the other. So I'm going to say that congruent triangles implies corresponding parts congruent. All right, and that is it for that proof. We're going to just do a few more. We're going to skip over a bunch of problems, which if you ever want to come back and work on some of these, it's not a true proof. It's just like explaining one thing. So I want to just practice true proofs because they'll help you with everything else. All right. So let's look at problem. Let's look at problem 8. Okay, I'll leave 7 for you to try. And if you need help with it, like I said, jump onto a Google Meet with me and I can walk you through it. But if you feel like you know how to handle it, you probably do. If you're completely lost and confused, you might want to jump onto a 12th period Google Meet with me. All right, so number 8, statements and reasons. All right, so to start, we have our given, whoop, go sideways there, that PQ is parallel to ST. You're also given that R is the midpoint of QS. That's all given. All right, so the first piece of given, that PQ is parallel to ST. I'll put my arrows to indicate it's parallel. And then R is in the middle of SQ. So if R is in the middle of SQ, what does that allow you to conclude? If R is the midpoint, that means that RQ is congruent to SQ, or SR, excuse me. So RQ is congruent to SR, and that's simply by the definition of a midpoint. Now, I'm probably going to run out of room. Yep, the T ran off. Now, it moved on me. Let me put the markings back where they belong because the thing moved on me. All right, so we had parallel, parallel, congruent, congruent. If you're given parallel lines, again, you should be looking for and thinking about alternate interior, alternate exterior, corresponding, same side interior. So if those lines are parallel, that means that angle 1 is alternate interior and congruent to angle 4. It also means that angle Q is congruent to angle S. So I get 2 congruency statements out of 1 piece of information. So I'm going to list them both. Angle 1 is congruent to angle 4, and angle Q is congruent to angle S. And that's all based on parallel lines imply alternate interior angles congruent. All right. Now, after you prove that alternate interior angles are congruent, you have your 3 congruency statements, your 3 stars. Look to see if you can prove that look to see if you can prove that the triangles are congruent. I'm going to just get rid of my arrows to simplify what I'm looking at. All right. Do I have enough information, as I'm trying to add all my markings back, to prove the triangles are congruent? You do, by angle, angle, side. So by angle, angle, side, you can say that triangle RQP is congruent to triangle RST. Now, before we move on, if I use my vertical angles in my proof, which I could, if you want to list that angle 2 is congruent to angle 3, vertical angle is congruent. Instead of angle, angle, side, you could use angle, side, angle. So let's say, for instance, I didn't say that Q was congruent to S. All right, if I just said angle 1 is congruent to angle 4, and angle 2 is congruent to angle 3, and these two say, then you could use angle, side, angle. So your proof might look different than mine based on what information you provide. All right, now that I know the triangles are congruent, my 5th and final statement, which I have to add over here, is that PR is congruent to TR, and the reason is because my triangles are congruent, so congruent triangles, that implies that all corresponding parts are congruent. All right, any questions about that? All right, I think I'm just going to do one more. I'll do the harder of the 2. I think it might be a little more challenging. Let's go down to number 10. All right, so for number 10, set up statements and reasons. All right, and we'll write down the givens. Whoop, it's not very straight. The given is that AD is parallel to CE and that B is the midpoint of DC. And you're asked to prove that B is the midpoint of AE. So we'll talk about how we can prove that after we prove the triangles are congruent. That's always going to be the first direction. Prove the triangles congruent, and then we'll go from there. So this is all given. Now, based on the given, all right, AD is parallel to CE. B is the midpoint of DC. If B is the midpoint of DC, what does that allow you to conclude? That DB and CB are congruent. All right, so we're going to say that segment DB is congruent to segment CB, and that's based on the definition of midpoint. All right, after the definition of a midpoint, and my page moved on me again. Oh. Put my markings back on. So this is congruent to that, and this is parallel to that. Let's use the parallel lines. Parallel lines cut by a transversal. I'm going to say that angle 1 is congruent to angle 6. Alternate interior angles. Now, 2 and 5 are also congruent, but I'm going to do this proof a little bit differently than I did the one above, just so you have another example to look at. All right, so angle 1 is congruent to angle 6, and the justification is parallel lines implies alternate interior angles congruent. All right. I'm sorry, my handwriting is so sloppy. It really isn't this sloppy in real life, but with this tablet, it's a little sloppy. Now I'm going to use my vertical angles because I didn't do the proof above using the vertical angles, so I want to show you using vertical angles. So angle 3 is congruent to angle 4, and that's because vertical angles are congruent. And now I have my 3 congruency statements, my 3 stars, and it looks like the triangles are congruent. And erase those arrows so they don't confuse you with tick marks, okay? They're congruent by angle, angle, side, angle, angle, side. So I can say that triangle ABC is congruent to triangle EBC by angle, angle, side. Once the triangles are congruent, that means all the pieces are congruent. But notice you're not asked to prove that the pieces are congruent. You're asked to prove that B is the midpoint of AE. Well, if B was the midpoint of AE, what would that mean? It would mean that AB is congruent to AE, which we now know because the triangles are congruent. So for problem 6, I'm going to say that AB is congruent to EB, and that's because your triangles are congruent. So congruent triangles implies, and I'm going to make the notation a little bit shorter. Instead of saying corresponding parts congruent, you can just say congruent triangles implies congruent parts. Makes it a little bit shorter, the hand notation, congruent parts, all right? And then number 7, keep running out of room over there. Number 7, now that I know that those 2 segments are congruent, that means that B has to be the midpoint, right? B would have to be in the middle in order for those 2 segments to be congruent. So B is the midpoint of AE, and that's simply the definition of midpoint. All right, guys, so that is all I'm going to show you for the proofs. I showed you 4 examples. I've left 2 for you to work on, practice on your own. So give them a shot, see how you do. If you feel pretty comfortable and confident, great. If not, jump onto a Google Meet with me at some point and let's work through them together. All right, bye.